Thanks very much. So SmartCityBus, this is a joint project, collaboration with between mainly Forth, a research center in Greece, and the University of Ioannina, also in Greece. So this is a project that's sort of halfway through its life, and today I will have three main points in my talk. One is the more developed area. The other two are mostly things we're thinking about. I'd like to share with you. So first, in SmartCityBus, we'd like to increase context awareness in transportation-related spaces. In essence, we'd like to put more detail out about buses and other transportation spaces, treat them more like the smart spaces that we usually treat buildings and other areas. This will provide additional properties we'll talk about, but it will also produce more data. There will be more data out to be collected compared to existing transportation systems. And looking at the servers, the context brokers that are serving these types of data, we're thinking, are they suitable for serving this larger amount of data, and also for the diverse data types we usually have. My third point will be about open data. We'd like the transportation data to also be openly available. That will spur innovation. But then again, looking at what is available out there in the wild, is it easy to leverage? Is it easy to use? So I will talk about a specific case study we did. So about context awareness, we believe that existing smart transportation systems, they lack full context awareness. There's more context to be collected and exposed. So this is in disagreement with IoT, the ecosystem out there. There's a lot of sensors installed usually in the stations, transportation stations, as well as the vehicles. This is not reflected in existing data models. Applications, vendor-specific applications exist, but they create lock-in. So we're interested to how can you do this in open data models, make this openly available. So our solution is to, well, first of all, we selected the NGSI-LD data model specification. This is an emerging standard by ETSI, which focuses on interoperability and data exchange in smart city environments. So we selected this and we extended it, particularly the parts about transportation, and to sort of represent static and dynamic context properties of transportation systems. On specific this work, there is a previous study we did that I urge you to look into it for more details. So, taking as an example a bus, one of these long buses, first of all, we model the vehicle models, the vehicle specification. This is the red box at the lower right, and we break this up into different spaces based on the function of its space. For example, the driver area, areas in the door, the disabled access area, and so forth. We also capture devices that are installed in these areas. And we capture also observations as they happen in time, as a time series. So this is quite a bit of information. And having that information, what can you do with it? Well, first of all, take as an example the area of where disabled people would like to use. So understanding the occupancy of those areas, that's obviously a good thing. You understand whether there's any free areas. to use. Think of the exact same thing on the bus station, the bus stops. Understanding the use of these areas really provides more information to the people who want to use them. Also, understanding the occupancy, not just on the entire bus as it's possible today, but on specific parts. One can imagine tuning the air conditioning to the specific areas. That saves energy, makes a much more comfortable experience. So I think this is something that's definitely good and possible with this new modeling, detailed modeling. Now, NGSI-LD, it does have some support for transportation models, but it's quite simple. So looking at the pre-SmartCityBus case, the existing models on transportation and urban mobility were quite simple, so we extended them. I won't go into too much detail, but in this slide you see how the model evolved. At the top row you see the vehicle model, vehicle and device entities that pre-existed. We extended those and we included the bus area and also the observation entity there, and we related them. So now it's possible to collect much more information dynamically. This is essentially starts looking like a smart space, just like we think of buildings and so forth. Some examples of how this actually looks like as we capture the data as entities as JSON objects. These are two bus areas, device and device observations, and that can accumulate as time goes by. Now, same thing for the bus stations and bus stops. This breaks down into the specific areas. Now, these are modeled in quite a bit of detail using two-dimensional coordinates or any other coordinate system one would like to use. So this is fairly detailed. So again, these enhanced data models, they enable new capabilities. Just one example is matching demand and supply in specific passenger needs, such as accessibility. An application that provides information to people that need accessibility based on how are things right now in the bus station, how are things right now in the buses that are coming over. This can be very useful. Can I be accommodated? I don't have to get into the bus to find out if I can be accommodated. I know what's coming. Also for the bus operator, finding out a pattern, finding out that certain times of the day, certain lines, the disabled area is full. That helps them schedule additional service was specifically targeted to that specific need. Right? The rest of the bus could be half full. That's fine. If that area is congested, then you can focus on specifically those needs. So it becomes much more specific. So now, what is out there in terms of data models in the transportation space? The prevalent data model out there is GTFS, the General Transit Feed Specification. This came off of Google, but right now is the de facto standard. GTFS and GTFS real-time, this is the real-time extension to it. And both of these provide information about static schedules of routes, but also the real-time positions of trains, buses, and so forth, but have no information about the internals, about the use of those vehicles. So GTFS really is the standard right now. In some countries, such as the UK, there are other standards, but these are less common and less open. So GTFS is really it. Now, in order to incorporate that information as well, to merge what's created and fed out there in terms of GTFS information and the information that IoT sensors report and about the internals of the buses. We merge them all within NGSI-LD. So we did that exercise, and right now we have the NGSI-LD model that contains all the information within a single space. Now, why is that a good thing? This is a good thing because the whole point about NGSI-LD is interoperability, is transcending smart spaces. So, taking as an example a smart port, it could be a whole smart city where you have multiple different areas here. In yellow, you see the transportation related. This is the city bus terminal within the port. But you also have the areas, the port authority areas. You have the areas where the boats arrive. You have the fire department. This is a different smart space. You have the first aid, the passenger terminal, the police and so forth. So this is about interoperability. If you would like these different spaces to exchange data, and if you would like to form complex queries about transcending these areas, and you would like the smart transportation to be part of it, then you need to be into such an interoperable data format. So our work will fit right into it, providing a lot of information. So moving into the SmartCityBus platform architecture, which is evolving, this is at the center of it is a context broker, because we're talking about contextual information about smart spaces. So an NGSI-LD context broker is at the heart of it. This is the one serving the NGSI-LD data model we created with multiple applications. This is essentially, it looks very much like a pub subsystem. It's a pub subsystem where applications can contribute data, they can subscribe to changes, they can also publish information. At the lower right, you see the data storage for these models. This is both static and real-time information. Now, we also have the back end of this, which is allows longer-term processing of that data. This is a different subsystem, which also contains raw as well as sort of processed results from analytics. Now, again, a lot of data being produced. We increase the amount of data that's being collected. So how is this architecture going to handle with so much data and of different types? Static, dynamic, historical, and so forth. This seems to be a challenge. So we have been building this prototype, which I won't get into detail here. This is essentially an implementation of the previous architecture, but just looking at the data repositories here, one will find multiple types of data repositories just because of the different types of data. Right, you would have key value stores, you would have a time series database, you would have SQL repositories and other types. So this is essentially a polymorphic store. This is a polystore. And an open question for us is, what is the appropriate architecture for that back end? Will existing solutions work, or do we need something new? And particularly for the transportation domain, this might change things a bit. So the last part of my talk is about open data. So there's a big discussion about open data. We'd like data to be open as much as possible. That spurs innovation. It allows application writers to train their models, use and create more innovation. But one question is about the quality of that data. Lots of data, but are they good data? Are they data that you can use without any mishaps? Can you trust that data? So in the transportation space that we've been studying, we took up an example. We looked up for data publishers, open data publishers, and as the GTFS specification is quite popular, we found a few that are pretty good about publishing a lot of data. So we took up the case of one public transportation operator. This is the Roma Mobilità in city of Rome. And we did an analysis of what they produce. So typically, they publish daily static data. This is the schedules, the bus schedules and train schedules, and which is about 300 megabytes per day. But they also produce a lot of real-time data about positions of these vehicles. So overall, looking over a day, this can amount to about 4 gigabytes of data, or about 22,300 trips. That's quite a bit of data. That's a few months ago. This may have changed over time, and this varies during the day, obviously, right? It follows the circle of the day. It's highest over the peak, during the day, lower during the night. So incidentally, I will not talk about this in this talk, but we found out that processing this data in a stream fashion helps a lot. Helps a lot reducing the raw data instead of storing all of it and processing it overnight. Doing stream processing helps a lot. So this is an interesting observation. So, what did we find about this data set? Mind you that in the past we had worked with specific vendors that produce AVM data. This is device-specific custom data from buses. And there we're quite happy with what we analyzed. Things made sense. Here, working with just open data with no links whatsoever to the data, to the bus operator, things were a little different. First of all, we found out that some trips in the feed could not be mapped to the schedule, right? We couldn't find them in the schedule. That wasn't too much. It was about 3% of the trips. Also, scheduled trips that should be in the schedule were not seen at all, and that was much more. So about 46% were not in the feed. And then we moved on to doing some statistics on the schedules, and we found that quite a bit of inconsistencies. So looking at this bar chart here, this counts the number of trips that on specific delay intervals. So we saw that a lot of the trips were actually arrived much sooner than their schedule, 5 to 10 to 25 to 15 to 20 minutes ahead of their schedule. This looked kind of suspicious to us. We didn't quite believe it, right? But this raised sort of doubt as of if we were an application provider for a transportation application, could we trust this data? Could we trust this data and offer this application to customers? The answer was probably not, right? Probably not. And here, the point here is that open data in the wild raise quality issues. You cannot be sure that what you're processing is actually can be trusted. And so this is an area where we'd like to improve things. Now, the obvious solution is to talk to the bus operator, talk to the data provider, and ask questions. Does it make sense that so many trips are ahead of their schedule for so? This could be the case, or it could be just errors in the data. It could be lots of different things. So the solution is talk to the data provider, but this does not scale. There is an issue of scale here. So there might be other ways that the data provider could vouch for the quality of the data. So we're looking into ways to make that a bit more automatic. And this is actually a big strategic direction in Europe. There is the so-called the European Open Science Cloud Association, the EOSC Association, whose purpose is to make data more openly available, as well as open science in general, and ways that this can happen. So we're following closely this movement, and this is something we would like to do more in the future. So to conclude, so SmartCityBus is a large project, kind of halfway through its life. The major thing we've done so far is to change the context awareness. More data from buses, bus stops, make this more of a smart space domain, as opposed to just tracking these big vehicles around. The key thing is that once you do it, not only you will learn more about what's happening in those vehicles, but you will also be able to interoperate with other smart domains. This is very important. There will be many and diverse forms of data. How can you handle them in context brokers, the major servers for this type of information? And also open data, so how to improve the state of things in open data, and this way to facilitate exploitation of these very useful data sources. Several other directions are under investigation, so you will hear more about SmartCityBus in the years ahead. So for now, I'd like to point you to one other publication we have, which talks a bit more about the context awareness that I spoke about. And before closing, special thanks to all the members of the consortium for this research. And with that, I'll be happy to take any questions. Thank you.